Okay, section 1.3, recalling prior knowledge. So this is another section which should be pretty much 100% review, or at least the topic is something you should have looked at earlier, like in middle school maybe. And what we're going to be basically doing is, well, a couple different things. The first thing is going to be talking about converting decimals and fractions back and forth, but I don't know, that might be a little bit of a spoiler, but here we go. So, a question: which is the larger number? What's larger, 11/17 or 41/63? Which one's larger? Is it easy to tell? Here's my point to kind of cut to the chase. It's way easier to compare what than fractions? What would be easier to compare than two numbers that are in fraction form? Decimals. I mean, I don't know if you're going to argue with that. I mean, I guess everyone's entitled to their opinion, but I would dare say that most people, a strong majority of people, would say that it's much easier to compare decimals, overall, right? I mean, across the board. I know some fractions are easy to compare, but I think across the board it's much easier, in my opinion anyway, to compare decimals. So, man, it'd be really nice if these were in decimal form, because at least in my mind it'd be a lot easier to tell which one was larger, right? Again, I don't know if you're aware of this, there are ways to rewrite these numbers in different forms. So here we go. Let's review or talk about how to change fractions to decimals. Without a calculator, what that really means is sometimes you can look at a fraction like this one, and if you say this fraction out loud, the proper way, not 7/10, but what's the proper way to say this fraction? Well, the proper way is to say it as 7/10. Okay? Again, think about that. 7/10. Maybe you'll remember that 7/10 also describes this decimal. So literally, you call this 7/10, you call that 7/10. But here is how we're going to do it with a calculator. So for the most part, in this section and this stuff, we're just going to be going with a calculator. Okay? So 7/10. There happens to be a nifty fraction to decimal, decimal to fraction function on our calculators that we have in class. So the one I'm having right now, if you look for the F and then like the double arrow or the arrows D, or D arrows F, that's going to convert back and forth between a fraction and a decimal. So if I put 7/10 in as a fraction and then hit those correct buttons, and if you're unsure about what buttons to push, because I don't know what calculator you're using at home or in class, or maybe, I don't know, I mean, it's just if you can't figure out what buttons to push or how to enter this into your calculator as a fraction in the first place, just ask someone, or ask myself, better yet, ask me one-on-one in class when you get a chance. But the bottom line again is that a lot of calculators have ways where you can just literally have it convert for you. Another way is to just literally do 7 divided by 10 on your calculator. Okay? Because remember, and I'm sure I've already brought this up already, whether it was in section 1.1 or maybe last section. I know we're only on section 1.3, but I think I've already emphasized that a fraction is basically a division problem. So you could just do on your calculator 7 divided by 10, and it'll give you, I don't like that, 0. It'll give you 0.7. So again, 7 divided by 10, because again, like I've already, when you shade over the numbers, doesn't a fraction, you can, I guess I got to give Mrs. Clute credit for this, if you kind of shade over the numbers, the numerator and the denominator, doesn't a fraction basically look like a division sign? So again, the point is, fraction is division. So change these fractions to decimals. Quick, very quick, it's just 9 divided by 17. And this gets me 0.529411765. And I don't know, here's something you got to kind of remember going forward. If you can be exact, like at least with these problems anyway, but overall I would say if you can be exact, then be exact. You know, like if this decimal were to repeat a pattern, then you want to use that bar. I mean, I'm sure we'll see. I guess look at number 2. I already know in number 2 we're going to do that. But in this situation, I don't really see for sure on my calculator I'm using a repeating pattern. So I'm just going to kind of round. I'm going to round off to 3 places. So really, I'm going to put that symbol in there because that means approximately equal to, because I'm rounding. Okay? Maybe this decimal will repeat at some point, but I'm not seeing it, so I'm happy with just rounding off to 3 places. But 2/3, if you do 2 divided by 3, you get 0.6666666. That's going to be a repeating pattern. So in this one, I'm not going to round. I'm going to represent it as exact by putting a bar, and that denotes that it goes 6 repeating forever. 1/5, again, I'm just going to do 1 divided by 5, and that's going to be exactly 0.2 or 2/10. And that's that. You can also change decimals back to fractions. Okay, without a calculator, again, how do you say this? How do you say this properly? You don't say 0.62. How do you say that properly? Don't you say 62 hundredths? That's the proper way to say that decimal. Well, guess what? 62 hundredths is also a fraction. And you might need to reduce that fraction, but you know, that's what you could do. With a calculator, again, don't forget that we have that nifty function, that whole F arrows D, F to D, D to F thing. So all I'm going to really do, I'm just going to do it right now in live time. So as long as you know what buttons to push on your handy dandy, whoa, I misread that for a second. As long as you know what buttons to push on your handy dandy calculator, then just do that. And if you need me to point that out, what buttons to push on whatever calculator you're using, because every calculator can be, they can be different. There's a lot of different calculators out there. So just make sure that you know what you're doing. Okay, let's do that over and over again. 0.25. On my calculator, I got to do like a shift. You'll probably have to do a shift on yours. So I'm going to do a second, and this turns out to be 1/4. You may have known that without even cheating on a calculator. How do we do this with the bar? This is literally 0.44444 forever. So what do you do? How do you enter an endless number of 4s into your calculator. How do you do that? Well, the thing is you don't. You don't have to. But you do have to type in a crap ton of 4s. Like, don't just do 0.4, don't just do 0.44. Type in enough 4s where, like, you're pretty sure the calculator gets the hint that these 4s continue on forever. Or you type in enough 4s where, as far as your calculator is concerned, those 4s went on forever enough. That's weird to say. It went on forever enough. But anyway, type in a lot of 4s before you do the whole F to D conversion. And just make sure that you're able on your own calculator. Again, don't just be mindlessly copying these notes. Participate along here, and hopefully you have a calculator handy. Make sure you're typing in the right buttons where you can get your calculator screen to say 4/9. And then just one more quick example, 0.657 or 657 thousandths. But if I, on my calculator, that's what my calculator is saying. So I'm going to assume it can't reduce, because if it can reduce, then it's too big of a fraction for this particular calculator to handle. Hey, even calculators have their limits, right? Have their calculating limits. But I'm going to go ahead and assume that 657 over 1,000 cannot be reduced. Maybe I'm just being lazy right now. Sue me. Okay, so that was converting between decimals and fractions. And I hope that was at least easy, if not like a complete review that you totally remember from another teacher, another class in years past. So changing gears, now we're going to talk about a little bit of vocabulary and a couple different types of numbers, okay? Like sets of numbers. The first type of number is a rational number. This probably is at least vaguely familiar, the term rational numbers versus, and we're also going to do irrational numbers. So do you remember anything about rational numbers? What is a rational number? What makes a number rational? I don't know, I just feel like kind of elaborating a little bit. So maybe you remember other sets of numbers like the natural numbers or the whole numbers, like which numbers are the whole numbers, which numbers are the integers, right? And so on and so forth, right? So, but there's some number, you can call it like a number can be rational or not. So do you remember what makes a number rational? Well, let me also say this. Just want to give you your money's worth. The official definition of what makes a number rational or not, like this is the definition you would see like in a textbook or on Wikipedia or something. What officially makes a number rational is whether or not you can write it as a fraction. Okay, and obviously you got to be using nice integers, in your fraction, right? It can't be like 0.7 over 0.8. No. It's got to be a fraction using nice integers, and that's it. That's the official definition, whether or not you can write a number as a fraction. But there's maybe an easier way to understand, way to tell if a number is rational. Here we go. If the number has a decimal that ends, then it's rational. Okay? Like, and I'm not just talking about 5.72. And that's it. That decimal comes to an end at some point, and therefore it's rational. But guess what? The number 7 has a decimal that ends, right? 7.0, I guess. So 7 is rational because it has a decimal that ends, just like whatever I said a minute ago, 5.72, I can't remember. But so if a number has a decimal that ends, it's rational. But guess what? Numbers that have decimals that go on forever can also be rational as long as that decimal repeats itself in like a pattern, okay? Like 0.666666666, that goes on forever, but that repeats a pattern, and so it is also therefore rational. Like at least there's some rhyme or reason to that decimal. So some quick examples, I already gave you a couple there or whatever, but 0.5, that has a decimal that ends. It ends just after 0.5. 0.647, that is rational. 0.9 repeating, okay, that goes on forever, but at least it repeats a pattern, so therefore it's rational. And 0.256 repeating, 256, 256, 256, 256. And you know what, let's also make it a point to just write down 7, like I said, okay? Because those are also rational numbers. Conversely here, we have numbers that are irrational. Like if something's not rational, it's irrational, right? So use your common sense here and deductive reasoning skills. If rational numbers have decimals like this, what do you think the decimals would have to look like for a number that you would call irrational? What do you think? Wouldn't the decimal need to never end, and also never repeat? Yeah. You probably already know this, but there are numbers out there that have a decimal that goes on forever and in just random ways and never repeats a pattern. Okay? Again, think of like an irrational person. Okay, this is a pretty good word to use in this for this vocabulary word for this kind of number. Think of an irrational person, or like, hey, someone that's acting irrationally. Like there's no rhyme or reason to someone's behavior. You say that they're acting irrational. Well, think of a number where like this decimal just goes on forever and no pattern to it. It's got no rhyme or reason. So, do you guys know any examples of numbers that would have such a decimal that goes on forever, crazy, and never repeats a pattern? What do you think? Do you know of any numbers? Pi is one of those numbers, right? 3.1415, blah, 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 and it goes on forever, right? But never repeats. What else? Well, are you aware that the square root of 2, if you checked your calculator, which you should do right now, the square root of 2, that decimal, I think is like 1.41, and it keeps going, like forever, and it'll never repeat. So those, I think pi is a classic example, and any square root, well, how about that? There's a question. Will any square root be irrational? Think to yourself. Will any square root be irrational? The answer is no. Why? Can you think of a square root that's actually rational? I hope so, because think of the square root of 4. The square root of 4 is just 2, so it's rational. How about the square root of 25? That's just 5. So there's a lot of square roots, actually an infinite number, but square roots, there's a lot of square roots that are irrational. Most square roots are irrational. like square root of 2, square root of 3, square root of 5, square root of 8, square root of 10, square root of 15, square root of 18, square root of 26, square root of 27. A lot of square roots are irrational. And I think for like the final act here before the video ends, make sure at this time, like I don't want to go further in the class if you do not know how to operate and do square roots on your calculator that you use daily at home or in class. And if you can't, ask a buddy or better yet, ask me to help you properly operate the square root button on your calculator. Like, for example, the square root of 2, you should get like 1.41, blah, 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 blah. Or if you want to do like the square root of 9, you should be able to have your calculator say 3 is the square root of 9. Okay? And that's all, folks.